Okay, welcome to presentation 2 on calculating slope. Slope is something you should have learned in Math 10, so this should be a review for you, but you'll learn how to apply it to position time graphs and you'll learn the meaning of what slope means for a position time graph. The velocity of an object can be determined from position time data. For example, the following was position time data for an object moving at constant speed. So you can see here at 0 time, the object is at 4 meters. After 1 second, it's at 6 meters. After 2 seconds, it's at 8 meters. So it's going up by 2 meters every second. That means the speed is 2 meters per second. It's increasing its displacement by 2 meters every second. The velocity of the object can also be determined from the slope of a position time graph. Slope of a line is a measure of the angle that a line makes with the horizontal. Steps for measuring slope. Pick 2 points on the line. When you're drawing a line of best fit, you only use points that are directly on the line. They don't have to be data points. They can be any point on the line once you've drawn the line, but do not pick any points that are off the line. Measure the vertical separation between the points using y2 minus y1, also called the rise in math. Measure the horizontal separation between the points using x2 minus x1, also called the run. The slope of the line is equal to rise over run, which equals displacement over time. The slope of the line is equal to the velocity of the object. So here, for example, so you could have a line of best fit with points that go something like this. So you have 3 points below the line, 2 points above, and 2 points touching. Now, once you've drawn the line, you ignore all the points that are off the line, and you can use any 2 points on the line. So I can use these 2 points even though they weren't data points. Once you draw the line, you have a lot more data to work with. Sometimes it's best to use the end points because you want as much separation as possible between the points, but you don't have to. You'll get the same value if you use these 2 points for slope, this one and this one, as you would if you use this one and this one. You'll get the same value for the slope. So slope equals rise over run. Your rise is your delta y, which equals displacement. So that's your delta y. And your delta t is your horizontal separation, which is equal to delta x. And your slope is equal to delta d over delta t. And that's essentially the equation for velocity. So we can calculate the slope of this line. We pick 2 points. So I arbitrarily chose these 2 points here. And slope is equal to 18 minus 4 over 7 minus 0, which equals 14 over 7, which equals 2 meters per second. Any 2 points can be used to determine the slope of the line. The slope represents the speed or velocity of the object at any point along the line. So step 1, determining slope, pick 2 points. I'll pick these 2 points. Label the points with your x and y coordinates, distance and time. Find the rise, which equals y2 minus y1. In this case, it's 16 minus 6, which equals 10 meters. Find the run. In this case, that's x2 minus x1, which equals 6 seconds minus 1 second, which equals 5 seconds. Find the slope by dividing the rise by the run. So slope equals rise over run, 10 meters over 5 seconds, which equals 2 meters per second. Notice it's the same as the slope that I got using the two previous points. So same slope, I use these 2 points initially. I get the same slope. Take a moment, pause the video, and calculate the slope of the following line. Okay, if you've done it correctly, it's 20 meters per second. If you made a mistake, ask your teacher for some assistance and make corrections. Otherwise, you can move on. Slope may be positive, 0, or negative. Positive slope, the line slants up and to the right. The velocity of the object has the same sign as the slope, therefore the velocity is positive. The object is moving in the positive direction. 0 slope, the line is horizontal. The slope is equal to 0. The y2 and y1 values will be equal. So the numerator becomes 0 in the slope calculation. Therefore, the velocity is also equal to 0. And it means on a position time graph, a horizontal line means the object is not moving. Negative slope, the line slants down and to the right. In this case, y1 is greater than y2, so the numerator in the slope calculation becomes negative. The object is moving in the negative direction. The velocity is also negative. That concludes the presentation. You can move on to the graphing assignment. You can use a piece of graph paper to make your graph. And once you've labeled it, the title, axes, calculated the slope, and drawn the line of best fit, show your teacher and he or she will check to see if you have done it correctly.